Hey everyone, my name is Paul Reese and I'm a developer programs engineer on Firebase at Google. Today we're going to talk about two tools, Flutter and Firebase, and how they can be used for rapid prototyping. So the way this talk is going to be set up is that I have my slides, but I'm also going to do some live demos and show you the code for both some basic Flutter widgets as well as Firebase being used with the Flutter Fire plugin. So let's go ahead and get started. So whether it's at a hackathon with only one weekend to build something presentable, or you have an idea for an app that you want to test out before really investing in it, a lot of us have been in a situation where we want to quickly build something that gets the job done. During the normal prototyping development process, developers plan out what the app should do and how it should function, research the feasibility of the idea, map out their architecture, pick their tools, and then build a clean and organized prototype, right? Yeah, I don't know anyone that does that either, honestly, for prototypes. So when building out a quick prototype, most of us just want to open up an IDE and start coding. Then we'll figure out the rest as we go along. Given this, I'm going to talk about the two tools I mentioned earlier, Flutter and Firebase. Both of these are easy to use and address different development problems. Flutter is for client-side development, and Firebase is for the backend. While I'm not going to do a deep dive into either of these, what I hope to do is at least help you leave with the vocabulary to look into both of these tools further when you're ready to use them. First, let's talk about Flutter. It's a UI toolkit that uses the Dart programming language for building native apps for multiple platforms on top of C++ using a 2D engine called Skia, which happens to be the same graphical engine used by Chrome, Android, and a few other platforms, all from a single SDK. Since everything is built from a single codebase, you can create your prototypes for multiple systems such as Android or iOS without requiring specific developer knowledge about each platform. Flutter is also completely open source. Not only is Google working on it, but so are many members of the developer community. So rather than being walled off from the internal workings of the tool, you can dig into the code to see exactly how Flutter is doing what it's doing, as well as send your own pull request if you want to improve it. So aside from Flutter being cross-platform, you're probably wondering why you should use it for rapid prototyping, especially since other tools exist that do similar things. Like most development decisions, the answer is basically, it depends. While Flutter isn't the only tool that can work cross-platform, it is designed from the ground up specifically for creating apps quickly. It's able to easily tie into device hardware using plugins and packages that can be imported into your project and uses widgets, which we'll dig into a bit more soon, to create UI components programmatically rather than requiring something like a layout file or storyboard. One other feature of Flutter that I think is super valuable is hot reloading, so you don't need to restart your entire app to test small UI changes. Instead, UI changes will automatically be applied in your running app as soon as you change various values. Following up on the it depends answer, there's also going to be times when Flutter isn't the right solution for you, and it's better to figure this out early in the development process. While games are a lot of fun to develop, Flutter just isn't really at a point where you can make a good game quick enough to call it a rapid prototype. You'll need to write a lot of the components from scratch that other platforms currently give you out of the box. Additionally, calling native APIs directly just isn't really a thing. Normally, you'd write native Swift or Kotlin code and use platform channels to communicate back and forth to the native level through a bridging process. While this isn't necessarily a deal breaker, it is more work than just throwing some UI together and calling it good. The next thing to consider is audio support, or rather the lack thereof. While audio isn't supported by native widgets, there are third-party plugins out there that can provide this functionality. Which brings me to my next point. While there's a ton of plugins for Flutter, some third-party libraries that developers have grown to love just aren't supported right now. You'll have to weigh the necessity of things like that versus working with what Flutter has before deciding to use the tool. Finally, Flutter doesn't have support for additional form factors, like watches, televisions, and cars. Right now, Flutter has very limited support for Wear OS, but no support for platforms like tvOS. Like we've talked about already, one of the big draws to Flutter for rapid prototyping is that it's an easy-to-use tool for creating custom UIs. Over the next few slides, I want to give a brief overview of how Flutter can be used to build UIs, then go into where you can learn more about Flutter and what it has available. The first thing I want to touch on is how Flutter can be used on multiple platforms. We've all seen apps made with multi-platform tools where they just don't look quite right compared to the system standard UI, like apps on Android that look like they're designed for iOS. What makes Flutter handy here is that it is able to tell what platform it's on so you can apply the proper UI elements for your app based on the OS. We can see in this example here that we're using the same app, which we'll look at in more depth soon, on both iOS and Android devices, but they each look native to their respective platforms. Which brings me to our next concept. When you're working with Flutter, everything is a widget, and all UI is described by widgets in a tree structure. You could think of them like Lego bricks, where you just connect them together to build whatever you want. So while there are hundreds of widgets, I want to go over just a few at a high level to give you an idea of this fundamental part of Flutter. As a lot of you know, you can't really start with anything in software without Hello World, right? All Flutter apps use the main function as their entry point, and in there you can initialize various components and start your application. You can also see a center widget in this example, which will center your content in the middle of the device screen, and a text widget that, as you can probably guess, will show some text. The next component that I want to talk about is the list, since honestly most apps are essentially just list and detail screens. As you can see here in this demo image, there's a lot of stuff that you can do with a list, such as swiping to show an available action, but to keep everything simple for this example, we'll just look at the code for a basic list of items. The first widget here is the scroll bar. While it's not necessary, it does provide, as you can probably guess, a scroll bar on the side of a list so users know how far along in the data they are. After that is the actual list view widget, followed by a loop that creates individual list tile widgets that will be added to the list and displayed. At this point, you're probably thinking that I'm lying to you about how simple this is, especially if you're coming from the Android world of recycler views. So I have my emulator and IDE ready to go to show you all of these widgets in action in just a minute. And since they're more often than not the widgets that will actually be used in your list views, the last of the standard components that I want to go over are cards. This is the code used for that demo image on the last slide, and you can see it's also pretty lean. The size box means each card will have a predefined height, and that size box will wrap a child card widget which sets some general properties for the card, like the shape and basic behaviors. Next up is the child of that child, which in this case is an inkwell. The inkwell is a kind of interesting widget, as it's what the card uses to figure out interactive tap areas. Finally, that inkwell has its own child, which is the actual content of the card that the user sees. At this point, you should be seeing a pattern of widgets forming a hierarchical tree in Flutter, which is pretty important for understanding how the platform works. So like I mentioned a moment ago, I have my IDE and emulator ready to go so that I can show you these widgets working in real time. So let's go ahead and switch over to that now. So this is the Flutter Gallery app, which has a whole bunch of examples of different widgets that you can use in your own apps. And since this is completely open source and up on GitHub, you can view the code and take the widgets that you want to use out of this and put them into your own rapid prototypes. So let's go ahead and start by going into the material category, and we'll scroll down to look at the actual list widget. So here you can see that we actually have a very simple list that is displayed for the user. It has a circle avatar with a number in it, as well as a set of items, each of which are numbered for the row that they're in. This app also has the ability to show you the code for this app inside of the status bar, and it is also able to take you to the documentation for whichever widget you're looking at by clicking this icon in the top right corner. Let's go back to our app though and see how this is actually working. So if we pull up the IDE, where I have the code here completely from GitHub, we can see our list view, as well as the children, which are going to be generated through a for loop, which each of those is going to create a list tile, which has our circle avatar, as well as the text that will be displayed in that list. So as you can see, it's actually really simple to put together a list view. Let's go back to the app now. We'll come back, and let's take a look at the card item. So you can see it's relatively straightforward. We've got a couple different options for our cards, some of them that you can long press on to actually select them, some that just have the ripple motion, and this one actually has some buttons with it. So I already have the code open for this as well, so let's go to that. It's this cards_demo.dart class. And let's just go ahead and scroll down. Should be able to find where the cards actually come in. So yeah, it looks like it's this part here. And here's where we actually have our flat buttons as well. So that would be this top card. And earlier I actually had mentioned that you can do hot reloading to check different UI changes and colors and whatnot. So these are actually this amber 500 shade item that's here. So I'm going to go ahead and get rid of this. Let's change this to green. So as you can see, it just changed there. Let's go ahead and change it back as well. So amber.shade 500, save, and we'll see it'll go back to what the original shade was. So in addition to this, the Gallery app also has these case studies, so you can see how you would actually implement some of these widgets in a pretty standard application. So if you wanted just a standard starting app, this one has most of the features that you would already see, like the side drawer, as well as a floating action button, some different text, share buttons, what have you. We can also see some really cool animations by going into this Rally app, which kind of just looks like a bank account, but if we click on some of these, we have a selection of different charts that you can work with. Let's see, I think there's one in here that has a really cool little graphic. There we go. So you can see how that actually fleshed out and spun and whatnot, and you have the different color codes for this circle. In addition to the material design though, you also have all the same standard widgets that you have for Android in iOS, but with the actual iOS styling. So we can see that we have like the progress loader or some of the other things that are pretty standard for them, like pull to refresh on their list. And that's completely out of the box. So let's go ahead and go back to our presentation and we'll see what else is available. Another thing worth mentioning is the Flutter Cookbook, which contains various code samples or recipes for common tasks that you might do in Flutter. So you can find this at flutter.dev docs cookbook. And this will have just a lot of code snippets that you can use within your app. So let's say we want to do something with networking. We can actually go down to that section and see how we would delete data from something that we have online, parse JSON, or even use WebSockets. There's also stuff for playing and pausing video, taking pictures using the camera. And so if we just go into that, we can see that they have all the code available and ready to go, so you can just put that into your applications when you need it. So they actually go over what the dependencies are going to be, making sure you actually have the cameras available, using the camera controller, the preview, and a few other things that are just really simple to use. While I mentioned earlier that all of the regular libraries that developers are used to using aren't always going to be available when using Flutter, there's still a ton out there to help you quickly build apps with complex features. So I actually really love maps in general, so I figured I'd mention Google Maps here, as it's a great little plugin that you can easily put into your apps when you want to show location information for your users. So here you can see that I have the Maps app running, as well as the code. So let's just go ahead and take a look at what this has available. So here's the build method, which is going to be where you end up starting. And what this is going to do is it's going to create a Google Map object, which has this onMap create a listener. If we go into that listener, we can see what the actual code is for controlling our map. So we have a markers map, as well as a circles map. And when this map is created, it's going to clear those out so they're completely clean slates. We're then going to loop over a list of these location objects for the Google offices. So if I just look at that here, I have this JSON file that has all the Google Office locations already set up. And for each of those, we're going to create a marker, set the location for it, give it a title and address, and then we're going to show a little red toast message whenever one of those markers are clicked on that'll show what the region is for that office. For each marker, we're also going to go ahead and draw a circle around it that'll have this kind of greenish light transparent color here for the actual part of the circle, and then a blue line around it. Once we have all that, we can go ahead and see where we have initialized our camera. So it's just going to go to 0, 0 to keep things simple. And then we set our markers and circles. So let's go ahead and look at our app from this. So I'm going to come over here and we can actually see all of the offices that we have. So I'll just go ahead and zoom in on the one that I have for work. Normally when we're actually able to go into the office. And you can see that we have our 3 different buildings. We have that light green circle as well as the blue circle around it. And if I click on it, it'll actually say the location is in Boulder, it has the actual address, and it'll show that it's in North America. The next thing I want to talk about is Flutter. This is a third-party library that I thought was just too cool to not include in this talk. So using their website, you can stage out animations that'll then get converted into a vector animation file that can be run in your app. This is great when you want to animate icons, buttons, or other items in your app to add some extra kick to your UI, which is always great when you're trying to sell an idea to someone or show it off for a hackathon judge. Overall, it took me roughly 20 minutes of a tutorial on YouTube to learn how to make this animation, and once you know how to put one together, it's really easy to actually make more of them. So this is the tool. It's at this rive.app website, and then you can just create your animations. So I actually have mine in here with various keyframes that can be used to mark off where the different changes are happening, such as changing the shape, fading in and out, and a couple other things. From there, you can actually export that animation as this FLR file and then put that into your applications. So this is actually all of the code that I have to include that animation in my app. So it'll create this flare actor, and then it will have the test animation file that I have, which is honestly just some JSON vector file, nothing too fancy there. Does some alignment and box fittings, and it tells it what animation to run, which in my case is just called Go because that's what I named it for my file. So if we go back to our application, let's go ahead and open that. And you can see that it'll run in our Flutter application here. For the second half of this talk, I want to go over what Firebase is and how to use it with Flutter using the Flutter Fire plugin. So let's go over the official pitch for Firebase first. Firebase is an application development platform with a mission to help app developers succeed by using Firebase products. Firebase accomplishes this by taking common problems and developer tasks that occur during a product's lifecycle and making them easier to solve, be it by providing more information about your apps and their performance, or providing tools to handle complex problems like security and network connectivity when storing data. Firebase is divided into three main categories of tools with specific goals: helping you build better apps by making complex coding processes easier, improving app quality by helping you catch issues early and fixing them quickly, and helping you grow your app by understanding how other people are using it and engaging with them in a meaningful way. As you can see here, there's almost 20 different products within Firebase. While this may not seem like a lot, today we're only going to look at a subset of all of the Firebase features that are most relevant to rapid prototyping. Again, the goal here isn't to overwhelm you, but rather let you know what's available when you need it. The first feature I want to go over is Authentication. While it's not the most flashy feature, there's always that one hackathon judge that asks about security, so you might as well toss it in since it's easy enough to use. This will allow your users to log into your app using a username and a password, a phone number, or a third-party identity provider like Google or Facebook. Next, I want to talk about the two database options available in Firebase. The first one, Cloud Firestore, is a database tool that allows you to group data using a document collection structure for straightforward access. This data is stored and synced between users and devices, plus it supports basic queries in addition to direct data access. The goal of Cloud Firestore is to provide a backend data storage solution without having to go through the tedious process of setting up your own database server, authentication schema, REST endpoints, and everything else that goes along with building typical database infrastructures. The second option, Real-Time Database, uses a simple JSON tree structure to store and access data. While more lightweight than Cloud Firestore, it still offers many of the advantages, such as real-time syncing, offline support, and scalability. Additionally, Firebase Real-Time Database supports the ability to know when users are connected to the database and can be used in conjunction with Cloud Firestore, as each can serve its own unique purpose within your apps. Sometimes you need to store and serve user-generated content, such as images or audio files, directly in your mobile app. You can do this using cloud storage. Uploads and downloads handled by the Cloud Storage SDK are resumable, making them more resilient to changes in network connectivity. When a user's connection is disrupted during an upload, the SDK will automatically handle retrying and resuming, which can be critical when dealing with the kind of network conditions often encountered on mobile devices. Downloading content uses a similarly robust system, allowing users to receive their data once a connection is successfully reestablished. Once the user's content is uploaded, it can be shared with other users for your app using the same SDK, and since you will likely run into situations where only certain users should be able to see or upload specific content, you can use Firebase's security rule system along with Firebase Authentication to restrict content according to your app's requirements. Cloud functions for Firebase are single-purpose functions that are executed in a secure, managed environment for your Firebase project. They are powerful tools that let you handle complex logical operations from within Firebase, such as performing operations on your Firebase database or interacting with various other Google or external services. These are great for handling backend logic in your app without setting up a complicated backend. The final thing I want to talk about is Firebase ML, which allows mobile developers to enhance their users' app experience by applying machine learning. Firebase ML provides a variety of models that can run quickly from the cloud with a high level of accuracy and detail. The out-of-box models allow developers to recognize text, label objects, and identify landmarks. Developers can also take their custom TensorFlow models and run them through Firebase's easy-to-use APIs. So what I want to do now is go back to our emulator and look at some of the Firebase features that are available using Flutter. So this app is just a collection of the samples that are available for Flutterfire. So what I'm going to do is go into Authentication, and we can actually see this page on the sign up page. So if I'm going to go into test registration, and let me actually go ahead and bring up our console. We can go to Authentication, and you'll see that there's currently nobody registered for it. So we're going to go back to our emulator. I'm going to go ahead and register ptreese.demo@gmail.com using the world's most secure password. We're going to submit that. So it says that we've successfully registered. So I'm going to go ahead and refresh, and we should see the user registered here. So that's the email that I just entered in. So I'm going to come back, go to the test sign-in page, and then I just signed out because it automatically signed me in when I did register. It's just the way this app is set up. But I'm going to go ahead and re-sign in. And it says again that we were able to successfully sign in. Another option that we have here is signing in using our email. So what this will do is it will email out a link to me using dynamic links. So if I send this, it'll actually send me an email with a link so I can just log in that way. So I'm going to send this. I'm going to go back. I'm going to pull up my email. And so there's this sign into project with a whole bunch of different numbers. I haven't customized the template yet. That's okay. So let's go ahead and sign in. And this will open up our application and say that we've successfully signed in. It'll also show me the UID for it, which, let me see here. That should be the same one, this MOZXD. Yep, and that looks good. So let's go ahead and sign out. And the last one I wanted to go over was how to sign in with Google. So what this is going to do is it'll give me this fancy UI that's actually built into the system where I can select the email that I'm already signed in with, and that will sign in. So if we refresh again on the authentication page, I should see that the Google provider is now available. So let's go ahead and look at the code for this. So here on the sign-in page, we can look for the Google sign-in option. So we have that. Here is this. And let's see. Sign in with Google. There we go. So what this is going to do is it's just going to use a Google sign-in account. It's going to go ahead and call that. It's all a part of an additional library that you can add in with Flutterfire. We'll call this Google sign-in authentication object. We'll get the credentials, and then we're going to convert that over to a Firebase user, and then we'll sign in using that. For the email link, we can find that real quick. So what will happen with that is it'll end up sending off the email link, and then when the app is open, we have this did change app lifecycle state method, which will be called when the app is reopened. It'll check to see if there's a dynamic link already set up. We'll take the initial link from that, and then we'll go ahead and handle it by calling this other method that I've just created to see if it actually has this user associated with it. Next, let's go ahead and check out the real-time database. So I'm going to go ahead and go back. We have the real-time database, and you can see that there's already items here. So if we go to our console, we'll go to database, real-time database, and you can see these items here. So actually, if we start modifying these from the app, you'll see that they change automatically, completely live. We also have this counter that's set to 44, and then it's displayed in our app. So if I keep hitting that, it'll create new items as well as modify that counter. And we can also change this by removing any of these items from any other app, and it should update in real time. So we can look at the code for this as well. So let me just pull up the real-time database code. So here's our counter ref, and so everything is going to actually use database references to set up listeners and actually understand when things are changing. And from there, we have a Firebase list in here. So there's our list tile for it. Here we go, the Firebase animated list. So this is actually what gives us the nice little graphic for things disappearing and then coming back. So they just flush in and just look really good as they're added in here. And what this is going to do is just going to listen to the messages ref, and every time this changes, it's going to make sure that the list is just representing exactly what was showing up in our data. So the last thing I want to look at is MLKit. So I'm going to go ahead and bring up the code for that. And we have these scanner utils. This is where we're actually going to be able to detect what's going on with the images. So we have this detect method, detect an image, And this will just go ahead and start doing all the processing depending on which algorithm we want to use. There's actually a lot of stuff that goes into this. There's multiple classes and whatnot as well. Again, it's machine learning, so it's not going to be the world's easiest thing, but it's a lot easier than other options that are out there that I've used. So just to show you this working in person, let's go ahead and bring up our app again. I'm going to come down to MLKit's picture scanner. I'm going to go ahead and open up a picture that I have saved on the device. So here's one with some of my pet chickens. So I'm going to select those. And what it'll do is it's going to do the cloud label detection, and it can see that it's looking at a chicken, bird, fowl, some other things with 99, 97, 96% confidence. So it's actually really accurate, which is pretty great. And then it was actually super fast as well. So let's go ahead and go back to our slides. And here I have a whole bunch of resources that are available if you want to learn more about Flutter or Firebase. So flutter.dev and firebase.com are going to be our main websites, and that's going to be where you find most of your documentation or any other kind of news that's coming out. We also have YouTube channels for both of these, Twitter feeds for both, and then just general code labs, the cookbook, and then the sample apps that we've gone over today, such as the Flutter Fire one on GitHub, as well as the Flutter Gallery. So again, my name is Paul Reese. Here's my email if anyone would like to reach out to me, but thank you for watching this presentation, and I hope you have a great day.